So, I've recently got my hands on this 270C Logitech webcam, which I bought for like 13 euros. You may be wondering why would I be interested in this thing? Well, turns out there is a way to convert this regular webcam into a particle detector. I had found a video about this project on YouTube and spent around 2 days searching for the software they were using, a so-called Theremino particle detector made by Lodovico Lapetito. It works based on the principle that a digital sensor on the webcam can act just like a semiconductor detector used in particle physics. When a particle hits the sensor, it interacts with the pixels on that region, producing an electrical signal, roughly the same way a cosmic ray can reach your Nintendo 64 and teleport you during your Super Mario speedrun. I have tried to build a detector before with a cheap NGS camera. I know, it looks like the most professional thing in the world. But it worked, and I was able to detect particles from a radioactive sample and even from cosmic rays. The results weren't quite as I expected though, so this time I went after the same camera used by Ludovico and found this more recent version of it for sale. I began by removing this plastic cover and the 3 screws that sat below. Once they were out, we can get a look at the main electronics. Here we can see the camera lens, as well as the microphone piece and this tiny LED. The light from the LED is guided through this transparent plastic to the surface. The first thing I did was to protect the area around the lens with electric tape, as the electronics on the PCB are quite sensitive. Then, I took out the lens, exposing the CMOS digital sensor below. In order to only allow particles of interest to reach the sensor, I placed a piece of aluminum foil held with more electric tape. A bit more of tape to protect the sensitive electronics, and this piece of paper to protect them from the dust that could enter the camera. I also placed extra tape over the LED. Alright, let's give it a try. Whoa, what is all this noise? Well, looks like there's some things that need to be fixed. My theory was that, because the electric tape wasn't completely opaque, and the aluminum foil was placed above it, there could be some photons that were still finding their way from the LED to the sensor. So, I had to open it again and start almost from zero. This time, I first placed the aluminum foil, then this different tape with a lot more of it over the LED. Only then I used the previous tape because it is overall better for electronics. The final result was this tiny volcano shape you see here. I also replaced the paper with this dark fabric piece I found. Besides these modifications, I have also set the minimum energy value to 20. Okay, attempt number 2. And voila, it's running much smoother now. Looks like there's still some noise, but way less than before. Now it's time for a real test. I left the detector running for around 12 hours. The number of detected particles, however, is still far out from the real count, so that has to be fixed later. Each white dot here is the result of a particle hitting the sensor. There are also a few lines, which happen when the particle comes at an angle. So there is quite some data to analyze, but that will be a task for later. For now, what is concerning me the most is the noise of the sensor. So, in part 2, I will be attempting to reduce it as much as possible and leave the detector as optimized as I can. Until then, have a good one, and I will see you next time.